Welcome to our lesson on writing inequalities. We've talked before about some of the different words and verbiage that we use to try and figure out what these different mathematical terms mean. We talked about sums and products and differences and, quotients and things like that before. Now we're going to expand that a little bit to understand how can we tell when we're going to have an inequality in the problem, because it may not just say it's going to be an inequality. We may have to figure this out. So you'll notice up at the top of your page, the notes are going to be the odd problems. So those are the ones we're going to work through. I'm going to do something a little different here too. Instead of writing on every single one, I'm going to go ahead. I've got some things written out, and as we uncover things, it's going to let me talk a little bit more while you're writing, or if you've printed the copy of the notes, kind of just see what's going on. So let's start here with what our symbols are and how this works. Okay, when the arrow is pointing at something, okay, that is when you're going to get into, for instance, your less than. Like here with this arrow, okay, if my x is going here, that would be less than. X would be less than whatever's on the right side of that, whatever number it happens to be. But whatever the arrow points at, that's less than. Okay, so then, and we'll kind of uncover some of these. When the arrow is eating something, okay, so let's say the x is here and the arrow is eating it, sort of like you may have been taught the alligator or some other thing like that. Okay, that's going to be is greater than. Okay, notice the word is in front of these, because you're like, well, less than was minus before and greater than was plus. Well, now, once you see the is in front, that typically means we're going to get an inequality arrow working through them now. And the only difference between those and the ones over to the right, you'll notice, is the line underneath. And all that means is we get the word or equal to in there as well. Okay, this still would be something similar to our is less than, and this would still be something similar to our is greater than. So as we take a look at the way these are worded, okay, is less than. X is less than 6. Is fewer than is another way of putting it. And these two ways of writing it are exactly the same. Notice in both cases the arrow is pointing at x. Now I could say this is 6 is greater than x, but typically when we have a variable, we speak in regards to where the variable is. Okay? On the next one, where the arrow is eating our x, which is greater than, okay, is greater than, is more than. Is the magic word here. Again, arrow eating x on both of these. These are equivalent. They're both x is greater than 6. Okay, when we get the or equal to part, is not more than, is at most, which means you include that number. Okay, is greater than means you're going to have bigger numbers than that. So like 6 wouldn't be included in this set. Here, okay, if I had the same thing, x is no greater than 6. Okay, it can be 6, but it can't be bigger. So we include is less than or equal to. Again here, is at least. X is at least 6. It might be more, whoops, but at the very least, it's going to be 6. Okay? So that's one of the things that we have to work on with this just a little bit. So as we continue to work our way down the page, between two numbers or a range of numbers, you may have numbers on both sides. Now you'll notice here, my arrows are both going to be going to the left, because here, x is going to be greater than my smaller number, but x is also going to be greater than or equal to my larger number. So if you ever have a range of numbers, and it's an inequality, but again, look for the magic word, is, that's what it'll look like. And we'll run into some of those. So for example here, 9 less than x is 5. Notice there's no word is here, so it's not an inequality. We talked about before how less than x is the opposite of what we'd think. If I want it to be 9 less than, I want to subtract 9. So x minus 9, my first part, is always like equals, and there's my number. And then I could go ahead and solve that if I wanted to. However, in B, x is less than 5. The is means it's inequality. Less than means the arrow is pointing at x. And then the 5. Because I could plug a number in here. Okay, what's a number that's less than 5? 2. 2 is less than 5. I just would plug the number in, and if I need to plug in a number to see if it makes sense or not, that's okay. Okay, don't let that kind of freak you out. Now again, we're going to be working on the odds, the ones to the left. Roberto weighs no less than 125 pounds. Now for the time being, let's just kind of look them up here in the top as we get them. Okay, weighs no less than 125 pounds. So he has to weigh at least that much, but he might weigh more. So here, Roberto is greater than or equal to 125. If he weighs 130, that's no less than 125, but if he weighs 120, that doesn't quite work for our purposes. So that's what we're on to go with here. So if we work our way down the page a little bit here, Mary has at least 8 goldfish. Where do you see at least? Right, over to the right. So she may have more, but she has at least 8. So is that greater than or less than? Ooh, greater than or equal to. Nicely done. Mary is going to have 8 or more goldfish. Okay? And again, put a number in if you have to and make it the inequality work that way. If you have to think of this as Mary has at least 8, so I'm going to pretend she has 10. Well, 10 would be greater than 8. The one thing that wouldn't bring into account is this or equal to sign. That's the one thing we have to keep watching out for. But if we understand the initial part, I think we can get that. Okay, Josh has at most $10 to spend. So could he have more or might he have less? With at most. At most, he's probably going to have less. So that's going to be less than or equal to. So that's what Josh has. And you can pick any variable you want. If you want to use x for every single one, that's perfectly fine. So as I keep working down, a number decreased by 4 is less than 14. Okay, a number decreased by 4. What would that look like? What's decreased mean? Decreased is minus. So x minus 4, whatever your favorite variable is, okay, is less than 14. So as the arrow, if I have my, I can't cover it up well enough. Okay, x minus 4 is less than 14. Because we always said less than, the arrow is pointing at the part that's less than. Well, the number decreased by 4 is the less than part. So that's how I figure this out. Getting there, we're heading towards the bottom of the page here. 40 is no greater than the difference of a number in 2. Okay, so think of it in pieces. So I've got 40. I have the difference of a number in 2. So now I just got to figure out what's up with the arrow here. 40 is no greater. It could be less than that. Or equal. And let's see. Does that agree? Yes. Okay. So just do it in little pieces. Don't try to take it in a big chunk and go in a hurry, because that's when we're going to mess things up. And then finally, 5 more than 3 times a number. Okay, 3 times a number. I want 5 more. And if somebody wrote 5 plus 3x, that would be okay. Is at least. Can it be more than that, or would it be less than that? At least means it could be more than that. Okay, and they are equal to 95. We match up. So far, so good. Okay, over to the back we go. If Sarah gains 6 pounds, she will weigh more than 113. How much does she weigh now? Okay, well, if you gain 6, what are you doing to Sarah's weight? You're plussing it. Okay, so if that happens, she will weigh more than 113. So you're like, wait a minute, we're doing something extra here. What's up with the extra part? Well, if Sarah, I could use S, gains 6 pounds, she will weigh more than 113. Notice I didn't do the or equal to because it doesn't say at least, it just says more. How much does she weigh now? I want to figure out what X is, or if you use S, what S is. So I minus the 6 like we would with an equation. I find out she's at least 107 pounds right now. Okay? So that's how we're going to look at these. After Mary paid $8.36 for a CD, she had less than $250 left. How much money did she have originally? Okay, so Mary paid for a CD. Well, what happens when you pay for something? Do you gain that money or do you lose it? You lose it. So we'd have Mary minus her $8.36 she paid, had less than, arrow points at it, $250 left. So if this were my inequality for number 15, how would I get m by itself? I'd have to add the 836, right. And once I do that, I end up with 1086. So Mary had at least $10.86 when she started. Okay? She may have had a little less. She certainly didn't have any more than that. So again, the big here is just taking your time with the way the words are written. Okay, 17. Mac paid less than $5.10 for a package of 3 golf balls. What was the cost of each golf ball? Okay, depending on how you wrote it, he paid $5.10 each for 3. Well, 510 divided by 3, that's where this $1.70 is coming from. Okay. Mac paid less than that. Now some of you may be looking at that and going, well, that looks like greater than. But remember, the two inequalities that I have here are the same thing. X is less than $1.70 per ball. Whether I write it this way or this way, if you just set up your original one and you'd have had, X is less than 5 divided by 3, that would work okay too because these guys are equivalent. And that's, again, one step, and we're pretty much ready to go. Helen and Grace must take in more than $150 to make a profit on some T-shirts they're selling. If each shirt costs $6.50, how much must be sold? Whenever you're selling something, you take the price of it times the quantity. Well, I don't know how many shirts I've sold yet. You guys can't even see the problem right now. What the heck? That's better. So $6.50 take in more than $150. So to solve this, what would I have to do since I'm multiplying x by 650? I'd have to divide. So divide by 650, and I get this funky decimal, and you're like, well, wait a minute, why'd you go to 24? I've been being taught since grade school that 0.08, well, that should round down, if anything. But so let's use some common sense. If I only sold 23 shirts at $6.50, let's check this out for a second. If I sold 23 shirts at $6.50, that's $149.50. Did I make at least $150? No, so I have to round up here. We have to be real life and not just sometimes what we learn in math class. So be cautious on that. I do all the math work right, but I got to make sure I get it all set. And then this is a little introduction to what we're going to be getting at. The sum of two consecutive positive integers, now again, positive integers, non-fractional numbers, is at most 24. So like 7 plus 8 would be two consecutive integers, positive. 9 plus 10. Well, I don't know what either of them are for sure. I know that they at most add up to 24. So x would be my first number, sort of like the 7 was, and then x plus 1. My first number was 7, 7 plus 1 is 8. My first number was 9, 9 plus 1 is 10. So when I set that up, x plus 1, and since it's at most 24, it has to be equal to or less than that. So I'd go ahead and I'd combine my 1x and 1x is 2x, and I'd go ahead and solve it. And 11.5. Now again, math part of you says round up to 12. But if my first number is 12, and then the next one's x plus 1 makes it 13, that's 25. That's too big. So 11 plus 12 would be the two biggest numbers that I have. And I know it's a little bit tricky, but we're going to be talking about it quite a bit, and at least gives you some practice with inequalities. But if you have questions, let me know.